Hey everyone, and welcome. Today, we are going to dive deep into one of the biggest, most critical challenges in all of cybersecurity, vulnerability management. We'll uncover why so many systems are just left exposed, we'll look at the tools of the trade for finding those digital weak spots, and we'll see what it really takes to build a modern, effective defense. So it all kicks off with this one number, 38%. I know, it might not look like much just sitting there, but trust me, it represents a huge shift in how cyber attacks are happening right now. Just keep that number in your head for a second. So what's the link? What do some of the most massive data breaches in recent memory, think Equifax, have in common with 38%? Well, the answer is actually pretty simple, and it explains exactly why this topic isn't just optional anymore. It's absolutely essential. All right, let's peel back the layers here. The story behind that 38% is all about what we call the unpatched risk. These are the digital front doors that organizations, maybe without even realizing it, are leaving wide open for attackers to just walk right through. Yep, you heard that right. That 38%, that's the year-over-year increase in attackers using known unpatched software flaws to get their first foothold inside a network. We're not just talking about phishing emails anymore. Attackers are actively scanning the internet, hunting for these specific weaknesses. Leaving a critical vulnerability unpatched, it's literally like leaving your keys hanging in the front door lock overnight. So this brings up a really important question, right? If we know these risks are out there and we have tools to find these flaws, why on earth are so many critical systems still so vulnerable? It's not always just a case of negligence. A lot of the time, it comes down to complexity and a very common shortcut that, honestly, on the surface, seems like a pretty smart move. And that, my friends, brings us to what's known in the industry as the backporting dilemma. It's kind of a technical term, but it's basically what happens when you try to jam a modern security fix onto a really old system. It's a temporary patch that, you guessed it, can create some very permanent problems. So what is backporting, really? Okay, imagine you've got this critical piece of software. Maybe it's running a factory floor or a hospital's medical equipment. It's ancient, but it works, and upgrading it is just too expensive or risky. When a new security flaw is found, instead of replacing the whole system, your team tries to, well, copy and paste the fix from the new software version onto the old one. It's kind of like performing delicate surgery using borrowed tools, all to avoid a full-on organ transplant. And on paper, this logic almost makes sense. You find a flaw, doing a full system upgrade is way too risky, so you just apply this very targeted patch and you tell everyone, hey, it's fixed. But this is exactly where things start to go sideways. This step-by-step process seems logical, but it completely ignores all the hidden dangers that come with taking this kind of shortcut. Okay, so here's where that flawed logic leads you. First off, the fix is often totally incomplete. Yeah, you might patch that one specific hole, but you miss out on all the other security improvements that came with the full upgrade. This also creates what we call technical debt. Your system becomes this fragile, complex patchwork that's an absolute nightmare to manage down the road. And finally, and this is a big one, you run into major compliance headaches. Automated scanners, they don't see the patch. They just see an old version number and they flag it. And that can cause you to fail critical security audits for things like handling credit cards, which is known as PCI DSS. Of course, before you can even think about patching anything, you have to find the flaws in the first place. And that brings us to the tools of the trade, vulnerability scanners. Let's take a look. So in the scanner world, you've got a few big names that everyone knows. You've got commercial powerhouses like Nessus, which is super popular because it's so user-friendly. Then there's Qualys, which is this massive cloud-based platform built for huge enterprise companies. And on the other end of the spectrum, you have OpenVAS, a really powerful open-source option that's totally free. But fair warning, it does take a bit more technical skill to get it running just right. But here's the thing, and this is so important. The tool you pick is only half the battle. How you scan is just as crucial. Check this out. An external scan, which looks at your system from the outside network, might find a handful of issues. In this real-world example, it found just 5. But an internal agent, a piece of software running on the machine itself, gets a much, much deeper look. On the exact same machine, it found 264 vulnerabilities. The difference is it's staggering. It's a whole different ballgame. Okay, so you found a ton of flaws. Now what? Well, finding one is one thing, but knowing how truly dangerous it is requires a standardized measuring stick. For years, that stick has been the Common Vulnerability Scoring System, or CVSS, and it just got a major, major upgrade.
So, to put it simply, CVSS gives every single vulnerability a severity score, usually on a scale from 0 to 10, to help security teams figure out what to fix first. You see a score of 9.8? That's a drop everything you're doing and fix this right now kind of emergency. But the old way of calculating these scores had some pretty big blind spots.
The new version, CVS 4.0, is a huge step up. It's designed to give a much more accurate picture of the real-world risk. It gets rid of some old, confusing metrics and instead starts asking more practical questions. For instance, it doesn't just ask if a system is vulnerable. Now it asks, if this system gets breached, could the attacker then pivot to other, more critical systems? It also gets way more specific about user interaction. Like, does the user have to actively click on a malicious link, or can the attack happen passively, just by them visiting a web page? The whole goal here is to move beyond a single simple number to a much more complete and useful risk profile. So, we've got all these pieces on the board: the risks of unpatched systems, the tools to find the flaws, and the scoring systems to rank them. How in the world do you tie it all together into a modern strategy that actually works? Well, the answer is a framework called VMDR. VMDR stands for Vulnerability Management, Detection, and Response, and it's basically a continuous cycle built on 4 really key ideas. It all starts with asset management, because hey, you can't protect what you can't see. Then comes continuous vulnerability management, where you're constantly scanning those assets for weaknesses. Now, the third step is absolutely crucial: prioritization. Instead of trying to fix thousands of things, you use real-time threat intelligence to focus on the flaws that attackers are actually using out there in the wild. And finally, remediation. You close the loop by efficiently fixing the problems that matter most. And this quote from a Gartner analyst just hits the nail on the head. One of the easiest ways to completely fail at vulnerability management is to just run a scan and email a giant report with thousands of problems to your IT team. It's a recipe for burnout and confusion, and it pretty much guarantees that the most critical risks will get lost in all that noise. So, we're left with this one final thought. In a world where there are infinite vulnerabilities, but you have a very finite amount of time and resources, the most important question isn't, are we vulnerable? The answer to that is always going to be yes. The real question, the one you need to ask, is, do we know which of our vulnerabilities truly matter? Answering that is the real key to a modern defense. Thanks so much for joining me for this explainer.